Hello students, let us solve another problem on computing different entropies and mutual information. So in a university exam you will definitely get such type of problems. So the problem statement is a channel with 3 input x1, x2, x3 and 3 outputs y1, y2, y3 with noise matrix as shown below. So this one is your channel transition matrix or noise matrix we can say. So input we write it here, that is for rows we write input. So x1, x2, x3, y1, y2, y3. Calculate hx, hy, hxy, hy given x, hx given y and ixy. They have given the input probabilities. They should give the input probabilities if they have given you the conditional matrix or channel matrix or channel transition matrix. So px1 1 by 8, px2 1 by 8 and px3 6 by 8. So if you have to compute all these entropies, the method I am telling here, you should follow that method only. Then only it will be, you will solve the problem in very short time. If you, and what is that method? That method is first you compute hxy. First compute hxy, this one. Don't go for hy by x and hx given y. In many books they solve for hy given x, then hx given y. After that they compute hxy. So if you remember, in the formula of hy given x, the probability is you have to use. So I will write here that formula so that you will understand what I want to tell you. So okay, here I will write. So h x given y. This formula is summation I equal to 1 to m, summation n equal to 1 to n, p xi yj log 2 of 1 by p xi given yj. So here for computing hx given y, you have to see for these joint probabilities as well as conditional probabilities. And if it is hy given x, then summation I equal to 1 to m, summation हे काय लिहिलं मी इथे j equal to 1 to n, pxi given yj log 2 of 1 by p yj given xi. So for computing these conditional probabilities, you have to see for the joint as well as conditional probabilities. But the formula for hxy is summation I equal to 1 to m, summation j equal to 1 to n, pxi yj log 2 of 1 by pxi comma yj. That means you have to see for joint probability only. That's why I told that's why I told to my students also that first compute hx comma y. Don't go for these. And all these formulas we have seen in the previous videos. Okay. So let us move on to our problem. So pxy. So if you want to find the hxy, then you need px comma y, this one. And you know how to compute pxy. In this channel matrix, multiply this row with px1, multiply this row with px2 and multiply this row with px3. So same is done here. This matrix first row px1, second row px2, third row into px3. So you got px comma y. Now after that you have to find hxy. hx comma y. So when you have to compute hxy, don't look for its that summation formula. You just see how many just see the these probabilities. So in this probability, 0.75 comes for 2 times, 0.075 comes for 2 times. So 2 into 0.075, log 2 of 1 by 0.075. Next, 0.025 comes for 1, 2, 3, 4 times. Okay, 4 into 0.025, log 2 of 1 by 0.025. You know na formula for entropy, that is P log 2 1 by P log 2 1 by P. So how many P? 2. So 2. Now 0.15 is there, 1 2. So 0.15, 2 into 0.15 log 2 of 1 by 0.15. This take 1 minute. So this is 0.15 and this one is 0.025. Okay, so then 0.45, this 0.45, so 0.45 log 2 of 1 by 0.45. After that, you know that we convert this log to the base 2. This is log to the base 2 to log to the base 10. For that we do log to the base 10, log to the base 10 2. So log of 2 in calci, you know this one na? Because we have solved many problems on this. So log this log 2 0.3010. So 0.3010. So I have written here 10. After that it is not needed you to write 10. Here it is required because here the base is 2. So 2 into 0.075 log to the base 10 1 by 0.075. Now here everywhere you will get here log 10 and how to find that in calculator. Suppose log this one na 1 by 0.075. कैसे यूज़ करना तो आता ही होगा ऑलमोस्ट ऑल इंजीनियरिंग स्टूडेंट्स. 1.1249. Okay, so I have calculated all this in the calculator and we got the answer hxy is equal to 2.43241 bits per message. This is average information, that's why bits per message. Now hx is how many probabilities? 1 2 3 probabilities. In that 1 by 2 1 by 8 and 1 by 8 are coming 2 times. So 2 by 8 log 2 of 1 by 8 plus 6 by 8 log 2 of 1 by 6 by 8. Again same, convert it into the to the base log 10. For that you have to divide every term you have to divide by log of 2. That log base 10 2. That's why I have taken it common. In many books they divide it here also log 2, here also log 2, then it will complicate the problem, or many times you skip that log 2. That's why better you take, if everywhere there is log 2, then better you take log of 2 outside, common to every term. So hx is, you got, if you solve it you will get hx 1.0613 bits per message. Now hy, for that you need y probabilities, and always remember this point also, don't compute y and x probabilities from transition matrix. You compute or you get the what x and y probabilities through joint matrix only. So addition of these will give you py1, addition of all this will give you py2, addition of all this will give you py3, addition of all this will give you px1, addition of all this will give you px2, addition of all this will give you px3. But not needed, already they have given it. If you count this you will get 1 by 8. If you add this you will get 1 by 8. If you add this you will get 6 by 8. So don't use this matrix. This is the important point. Don't use this matrix for px1 and px and py probabilities. Use this matrix only for px and py probabilities. So you got py 1.25, py 2.25, py 3.5. Again, three probabilities. How to compute entropy? Take the probability log of 1 by probability log of 1 by probability. So 0.25 coming to 2 times, so 2 into 0.25 log of 1 by 0.25 plus 0.5 log of 1 by 0.5 log to the base 2. So log to the base 2 को कन्वर्ट करना है log to the base 10. So divided by log 10 2 and log 10 here आएगा, here आ जाएगा log 10, here also log 10. If you compute it, you will get 1.5 bits per message. Then after that, use the formula hx given y is equal to hxy minus hy. So it is easy. Then computing hx given y in the first step. That's why I am telling you can use this formula hx y minus hy. क्योंकि फॉर्मूला हमने डिराइव किया है तो उसका यूज़ भी करना चाहिए. नहीं तो पहले अगर आप ये निकालोगे तो मैंने कॉम्प्लिकेशन बोला है कि आपको क्या, आपको यू हैव टू गो फॉर द ट्रांजिशन मैट्रिक्स एज वेल एज you have to see for the joint matrix as well as transition matrix. तो इतने फॉर्मूले है तो उसका यूज़ भी करना चाहिए. सो एच एक्स गिवन वाई इज एच एक्स वाई माइनस एच वाई. You will get this answer. Hyx is hxy minus hx. These formulas also we have seen in one video. There I have covered all these formulas. Ixy is hy minus hy given x, or hx minus hx given y, or hx plus hy minus hxy. Any formula you can use. So you got these values. So I will attach the PDF of this problem in the description box. You can take this because I feel PDF is required because there are calculations. For that you need the notes of this formula or copy of this problem. So you can go and refer that. So if so this is it for these problems. 2 problems are more than sufficient. After that there are only the changes in the bits, changes in the what we can say changes in the numbers. So you can solve there, solve any type of problem. So that's it for this video. Do consider subscribing to the channel and also give a thumbs up if you like this video. Also share with your friends because I feel these problems are very important, and the one specimen problem or one problem is more than sufficient to solve 100 types of problems, because the problems will be same, only numbers will change. And you should remember that rows are inputs and columns are outputs of the channel matrix as well as joint matrix, and use the joint matrix for finding px1, px2, px3 and py1, py2, py3. And third point is that first compute hxy, then hx hy, then hy, then hx given y or hy given x, and after that ixy. So thank you very much.